Kia ora koutou. I hope you're all doing okay. Um, our focus for this week is going to be on series and parallel circuits, sort of like what it was on last week, but this time we're going to look at the ideas of voltage, resistance, and current. So I'm hoping that the sound is coming through all clear, and we can go through this together. Just a reminder, this will be recorded, so you can come back to this at a later stage and use it to go through those slides at your own pace. You would have seen that I would have gone through all of your slides last week and left you a little comment, so more than happy to go and do that this week. So if you have any questions, you can leave them there, you can post them in the chat, or you can bring them to our Google Meet on Friday. Feel a little bit bad making our Google Meets on Friday in the afternoon. Unfortunately, the choice was either that or have it in the morning on a Thursday. And I felt like most of us probably wouldn't want to be waking up first thing on Thursday. And even though fifth period on Friday is not the best time, you've got to make do with the cards we've been dealt. So let's dive into the content and we'll get through that for this week. So our Te Rautaki Te Wiki is looking at these ideas of current, voltage, and resistance, and then looking at how they change in series and parallel circuits. Last week we showed you on the very last slide a bit of an introduction to this, and it involves some kind of complex ideas. It's unfortunate that we don't have the time to be in a classroom really to play around with these things. I'm hoping that maybe next term we'll get some time to have a bit of a play. So anyway, let's dive into these ideas. What are current? What is voltage? And what is resistance? So the first thing we want you to have a go at is making your own little circuit diagram, right? And seeing if you can notice the mistakes that might be occurring with this one. We want you to have a go at this and then post it onto the slide, or you can upload it as a new slide. But the answer to this one is a whole bunch of things. But you can see these sort of rules over here. We just want you to get in the habit of doing a good job when it comes to drawing your circuits, making sure the lines touch, making sure they're straight, making sure you're using a ruler, all of that sort of thing. This is kind of a really nice example of a circuit diagram because it's really easy to see that you've got a battery here containing two cells, you've got a nice little switch, you've got two bulbs wired up in parallel. So let's go into the content and the challenging questions that we've got for you this week. So the first thing here involves a little bit of a video. Now this video introduces you to basically all the key concepts, and here the people at SparkFun do a much better job than I think I could in explaining these concepts, so I'd encourage you to spend some time going through this. Your job is to answer those questions relating to the video. I know that that's quite a bit of thinking, but they kind of explain them very directly in the video, so work your way through there, and you can check your answers when comparing them to the next slide. So this slide here has all the answers for you. The key things to get here is the idea that current is about flow, right? It's about electrons moving through space. And in order to have current flow, you need a circuit to be all wired up. You also need there to be some energy source to give the electrons a push to move them through. We measure this flow of electrons in amps. And the more amps you have, the more of a flow of electrons there is. And we can actually measure the amount of amps using a thing called an amp meter. I sometimes say amp meter because it helps me to remember what it is, right? It measures current. Or a dim. I don't quite remember what DMM stands for. I'm sure you could give that a Google. All right, so definitions of electric current. We kind of talked about what this is already, but essentially all that current is the movement of electrons from one place to another. And in metals, as you're aware, electrons can kind of float around. That's what we feel when we feel a spark through a wire. And we talk about these electrons as being free. They're not really super free. They're kind of constrained. They've got to hang around in the metal as much as they can. But they will move if you are either pumping more electrons in or giving them a sufficient amount of a shove. And we can connect a little device that measures that. So now that we understand the flow of electrons, the next idea is the idea of the energy that they have inside them. So what is voltage? This video probably has the best metaphor for understanding exactly how voltage works. It's kind of funky because you can't really see voltage, right? But we can get a grasp on what it actually means and how it's different to current by looking at this. Once you've done that, you can also have a look at this sort of written definition. And this might suit you better if you're into reading stuff, or you might prefer the video. Either way is fine. But voltage is essentially how much energy is in a single electron, or how much energy is in all of the electrons when you add them together, right? And you can measure how much voltage is being used by looking at where the voltage starts and where it ends up, so how that energy changes. We can measure that with a thing called a voltmeter. Now, voltmeters have to be connected in parallel because you're measuring it like before and after. The good metaphor for this that I've heard used before is the idea of like a river. If you have a bunch of rapids, right, you might want to measure how much energy the water has beforehand, how much water the energy has after, and then figure out how much energy was lost by the water going through the rapids, going through the resistant, the kind of the pushback that you're going to get from pushing some water down some rapids. So what you do is you get your hand and you put one hand at the top of the stream and the other hand at the bottom of the stream after the rapids. And when you've done that, you'd be able to feel that difference. And that's basically what a voltmeter is, right? Being wired up in parallel. It's got one hand at the top, one hand after, measuring that difference. So now that you've done that, you should feel pretty comfortable to be able to start filling in this table. And you could give this a go. And then once again, because we're just so nice, we like to put in the answers there afterwards for you. So have a go at this. If you want to, you can pause the video now and try and enter it based on the knowledge that you've got. And I'll show you the answer in a second. 3, 2, 1. There you go. So the symbol we use for current is I, and the symbol we use for voltage is V. The major reason why we don't use A for current, because it's called an ampere, or we measure them in the units of amperes, is because we use A for acceleration, and we also use A for a bunch of other stuff, and it gets really confusing. One of the things that's unfortunate about only having 26 letters in the alphabet is that if you have more than 26 ideas, you all of a sudden start having to use the same letter twice. Or you've got to pick letters that don't entirely make sense. I'm sure there's a logical reason why we chose I for current. I don't know it off the top of my head, but that's the symbol that we use. So I is the symbol for current, V is the symbol for voltage. We measure current in amperes, we measure voltage in volts. You can see how you would wire up those tools to measure that difference, right? So there we go. Now you understand the idea of voltage, that idea of energy being used by an electrical system. You understand the idea of current, the flow of energy. The third key part of this lesson is on resistance. So resistance is something that is exactly what you think it would be. It's the pushing back against the flow of electrons. And usually that's because it takes the flow of electrons to power something. So you can think of anything in your house, right? DMM is a digital multimeter. That makes sense. Some of you might have access to a digital multimeter at home. Thank you, Finn. All right. So the resistance, coming back to that. So again, measured with a digital multimeter, which is quite neat, is essentially that push force against that flow of electrons. And you can basically think of anything that's powered by electricity is going to require some resistance to be overcome. Resistance, you normally just draw it with like a little wiggly line or a little box like is shown there. But you might sometimes see them with an arrow drawn over the top. And the arrow drawn over the top represents that resistance is variable. The resistance can be turned up or turned down. You can imagine that a speaker that was playing music at a louder volume would require more electricity, so would put up more resistance, right? So variable resistors are resistors that can be changed, that can be varied, right? And there's a whole bunch of different things that are electrical components that essentially resist charge or act like a resistor. And there are times when you deliberately want to resist current because sometimes you've got a piece of electronics that you want to make sure isn't exposed to too high of a voltage or too much of a current. Um, and so you can use resistors to support those pieces of equipment to be managed safely. So now that we know that, we should be able to fill out this table. And I'll give you the answer here, right? The only funky thing you might not have seen before is the ohm. Now, ohm is one of our Greek letters. Greek? Right, Greek letter. And it's kind of funky. It looks like a dude with 2 legs and no torso. So they've got kind of like funky shoes. So that's a nice way of remembering it. And it takes energy to dance. No, you can come up with a better metaphor than me for this one. But ohms are a symbol for resistance because we ran out of legit letters and we decided to start using other languages letters. I think also physicists have an affinity with Greek, so they're like big fans of using letters like that. So you might see omega and alpha and all of that sort of stuff in physics as well, which is kind of cool. So ohm meters can be connected however, so either series or parallel, depending on exactly what you want to measure. But essentially, it's just measurements of resistance. So now you've got all the fundamentals. You know about current, you know about voltage, you know about resistance. If you want some extra for experts, there's an opportunity here for you to explain these concepts using a football metaphor, which I'd encourage you to give a go. And then this all relates to what we talked about last week at the very end, that kind of extra for expert stuff that was kind of preparing you for what we covered today. There's also some more extra for experts, which is if you're feeling brave, and I think some of you will be, this is NCA, this is year 11 stuff. But that's all the information you need to be able to answer an NCA level question. So I'd encourage you to give that a go, and that mark scheme is available there for you. So that's the end of lesson 1. Now we're on to lesson 2, current in series and parallel. By the way, as we're going through this one, feel free to fire away your questions if you happen to have any, or make a note of them and bring them to our Google Meet later on. All right, so your first task here is again about drawing circuits. The reason why we're getting you to do this again is because it's a challenge and we need you to be practiced because we're going to ask you to do it at the end of the year, or at least at the end of the term as well. So here you've got a circuit with 3 cells, right? Remember, cells are those things that make up batteries, and has sort of 2 paths for the energy to travel down. One of them has 2 light bulbs, the other one has 1 light bulb. The single light bulb should be controlled by a switch, and the 2 light bulbs by another switch. You want a 3rd switch that can turn on and off all the light bulbs. So if you break it down step by step, you should be able to do this. I'd recommend doing it with a pencil and going step by step through the whole thing. And the answer will be on the following slide. It's actually in the thumbnail. But anyway, all right. And I'll show you the answer in 3, 2, 1. Here we go. So yeah, you can see 3 cells here make up our battery. Then you've got your 1 path with 2 light bulbs, another light bulb here. The ammeter is connected in series on the path with the 1 light bulb, which is quite neat. You can see that each of these paths could be turned off. So you could turn off these 2 light bulbs here and have all the current flowing through this lower path, or you could open this one and lower this one, and so you'd have all the electricity flowing through these 2 bulbs. Alternatively, you have a 3rd switch here, which is outside, and if you put it over on this side, that's fine too, because if you were to turn this one so that it was open, all of a sudden no flow would occur because there'd be no closed circuit, right? So if you get that, that's cool. All right. Now we've got a series of videos, or at least a couple, looking at ammeters and looking at light bulbs. So this is an opportunity for you to kind of get your head around those ideas of how do light bulbs actually work, how do ammeters actually work, and so get you thinking about what if we made certain changes to these circuits. It's the same with this one here. And what I'll do at the end of this week is I'll go through and I'll check over your answers and I can give you some feedback on these. So have a go at those, do it as best you can. These videos will help you to answer those. Lastly, our last 2 chunks of the lesson, are to summarize your understanding. Now, this all relates basically directly to the checklist, which is our goal for your understanding for the whole topic. So if you're able to go through these points in the checklist, then you should feel pretty confident about your understanding of these ideas. If you've got things you're not sure about, particularly about this E level part here, understanding how current and resistance affect the brightness of bulbs, you can say, I don't know, or ask for a little bit of an explanation, or you can bring that as a question to me when we have our Google Meet, and I'll do my best to answer. Lastly, you can pick between here, because that's quite a bit of work to do, and you can summarize your understanding. If you're feeling like a challenge, have a go at both. And there's a couple of pages here with some understanding, but it's all sort of practice, right? And that's the major thing with science, is that with the stuff around currents, the more you do, the better you get at it. Now, I know it can feel quite overwhelming going through these things, so by all means make a start, make a note of the questions you're finding too challenging, and bring them to our Google Meet, and we'll go through them together. There's some more extra for experts there if you want it. All right, that brings us to the end of lesson 2. Our final lesson is on voltage. And we're looking at voltage in both series and in parallel circuits, whereas last lesson we were looking at current. So, first thing, reminder of our first lesson, all right? How was voltage measured? What would you do? You can probably figure this one out. And there's some extra for experts here. Voltage is measured with a voltmeter, right? We use, and it has a symbol V, it kind of looks like this, and all it tells you is how many volts are being used across an area of a circuit. So you connect it at the top, you connect it at the bottom. Remember that river metaphor, it measures that loss of energy over that area, or the energy is being used to do something. Current, for those of you who did the extra for experts, is different. It's connected in series, it's measured in amps, and that measures that flow of electricity in amps, which is cool. Okay, so now same questions but answered in a different way. So you should be able to have a go at this, right? If you increase the resistance, what happens to voltage? You can probably figure this one out. And if you compare this one to this one here, this one asks you about it in a parallel circuit. So you'll find some interesting things here. This is kind of getting to the crux of like our understanding that we want you to have about series and parallel circuits. They treat voltage and current differently because of the way that their parts are organized. And these videos kind of help you to understand that, so I don't think it'll take you too long to go through those. But what you should get out of it is a good enough understanding to be able to answer these, right? And we don't need you to write paragraphs here. A single sentence, like explaining your idea, is all we need, right? Lastly, this is going to introduce you to our big concept, which I think we'll touch on more next week, which is on Ohm's law, right? Ohm's law links all of these things together, and you will kind of know Ohm's law based on your understanding of these, right? So take your time to work through the slides, and just take it step by step, and you'll be absolutely fine. Again, we've got some more options for you to summarize your content, and some more opportunities for you to practice, and some more extra for experts using these skills around voltage. Now that brings us to the end of lesson 3. Lesson 4 is all about review. So there's a little mahi there for you to ask, and to pop down any questions that you might have. There's also a little opportunity for you to revise the content, right? And you can be taking a look at this, so seeing where you are this week, ranking yourself. Might even be a good idea to pause the video and have a think about where you're at. And then there are a variety of options for summary tasks. Now you don't have to do all of them, but we'd encourage you to do at least one, all right? So those options are shown to you below. So this one is 2 slides looking at series and parallel circuits, and remember each of them has answers, so you can test your understanding on any one of those. Now, I know that that's a huge amount of content to be going through for this week, right? But you'll notice that some of those sections are just repeating the same ideas over and over again, right? The um, the key ideas we want you to be understanding are what is voltage, what is resistance, and what is current. And if you can do those things, then essentially each of those questions is just rephrasing your answer in a different way, showing that you understand those key concepts. What I would encourage you to do is to take some time to go through these videos or go through the slides step by step, right? And don't feel too overwhelmed. And if there's any parts that you are feeling overwhelmed with or that you are struggling with, highlight them, make a little comment next to them, whatever you need to do, and bring them to us in the Google Meet, and we can go through them together. Okay? All right. I'm going to leave it there for you, team, because you've got enough to be thinking about. If you have any questions, I'll stay around in the chat if you want to ask me anything. Otherwise, have a very lovely rest of your day. Look after yourselves, and I'll catch you later.